Today on the Road to Zero, we have Gray Alton, Vice President of Project Development at Terrapin Geothermics, joining us from Edmonton, Alberta. Welcome to the Road to Zero, Gray.
Yeah, thanks for having me.
And now, tell us, how did you get involved in the new energy? Because I think you had an engineering and marketing background, and now you're with a company creating for zero carbon energy.
Yeah, it's been it's been an interesting road. I grew up, born and raised in Alberta here in Edmonton, so kind of heart of oil country. I graduated high school not really knowing what I wanted to do, and the lowest hanging fruit opportunities were in the oil and gas field, and so I went and cut my teeth working alongside welders and pipe fitters in the field. Kind of learning the craft of industrial construction from the ground up. Eventually made my way to NAIT and took an engineering program there. And then, worked for in the general contracting industry, doing industrial construction, lots of EPC builds. And then, when this energy transition talk started to come up, I quickly realized that, I had helped build a lot of this oil and gas infrastructure that is causing some of the problems. And so I wanted to become part of the solution. And so I initially had invested into Terrapin to just as a passive shareholder, as part of the founding shareholder group. And then just because of my job experience in oil and gas, they approached me and asked if I would come on board and help them start bringing these projects to fruition. And so, I sit today as the VP of project development for them. So I kind of chase business development leads and work with our construction teams as well. And so it's been a fun journey.
Really cool. And give us an idea, what is the problem that Terrapin is trying to resolve, or what is it you're bringing as a solution?
Yeah, so we're targeting, emission-free power and heat wherever possible. So Terrapin has two verticals to our business. One is geothermal, and the other one is industrial waste heat recovery. Geothermal is a renewable power and heat resource, 100% renewable, 100% emission free, and it's also a baseload supply of power. And so that's where we contrast against wind and solar. When the sun's shining, you're getting a lot of great power, and when the wind's blowing, you're getting a lot of great power. But when it's an overcast day or a slow wind day, you can't generate. Whereas geothermal is a 24/7 baseload resource for emission-free power. And on the other side, on the industrial waste heat recovery, again, another baseload emission-free power generation resource. But on that side, we actually capture fugitive waste heat from, flue gas streams, cooling infrastructure, high pressure steam, anything that's getting vented off to atmosphere. We're able to capture that and pull the heat out of that resource and then use an emission-free conversion to create baseload power again with that. And so we help companies, that are looking to decarbonize their footprint. Maybe they have an ESG mandate internally from the corporate level or the board level that they need to meet. Most of the clients we work with have very large carbon exposures. So they emit a lot of carbon, carbon tax in Canada. Right now it's $50 a ton, escalating up to could be $170 by 2030. And so there's a large risk factor to them around that exposure. Facility reliability as well. When we're giving them that baseload power resource, they don't have to rely on the grid as often when they're getting consistent supply behind their fence. We're basically working with a lot of major oil and gas, steel, cement manufacturing, pulp and paper industries, just to help them, meet their ESG goals at the end of the day.
Okay, so I hear the really two places you're getting heat. One, you're getting it from the earth, and the second, you're getting from whatever man has made that is creating heat, and you're kind of capturing that heat that's just going to waste.
Absolutely.
So definitely want to explore both of those. So the first one for the geothermal, and then in the type of geothermal you do, it's not what you see like in Iceland, or you sit up close to a volcano where you have that nice heat. You're going after that a different kind of geothermal. So tell us a little bit more of what you're targeting and how you're getting that heat from the earth.
Yeah, so yeah, you hit the nail on the head. We're definitely not like Iceland, we're not, Alberta doesn't sit on top of volcanic formations. And so, in Iceland, you go less than a kilometer down and you're getting 1500 degrees plus Celsius. What we're doing is we are a conventional geothermal place. So I guess I should first contrast. There's geo-exchange, which is like using the earth like a battery, which typically you don't get power generation from, but we're more on the conventional geothermal side. So to access the resource, we're going to be drilling just shy of 4 kilometers into the earth on a vertical well to get to the formation. And we'll be producing about 120 degrees Celsius brine to surface. And with that brine is what will run through our heat to power technology to generate power. And then we'll also have an associated district energy network that will follow on to it, where we can actually transport that heat up to 7 to 10 kilometers away from that geothermal well to go and offset natural gas heating within facilities. They're using natural gas fired heaters for drying or something like that. They can then use this geothermal baseload heat to supplement that natural gas need.
Okay, so you're basically drilling down. You're getting this water that's hot from the earth, and are you just using a heat exchanger, and that goes back down in the earth to get warmed up, kind of as a bit of a loop?
Exactly. So yeah, heat exchange into a working fluid that we call it, and then it works just like a steam generation system, where yeah, we basically flash that working fluid. It turns a power turbine, and then we use air cooled condensing to reduce that back to liquid state, and then that geothermal brine just goes through the heat exchanger. We pull that latent heat out, and then we re-inject it into the ground. And so at 120 degrees Celsius, to be able to produce power, we're going to need to flow about 300 liters per second to be able to fill that flow rate requirement for our technology, which is a significantly high flow rate. To give you a bit of a contrast, so typical oil and gas wells will be in the range of 5.5 to 6.5 inch wells. We're targeting anywhere from 13 to 14-inch sized wells. And so we'll be drilling 3 production wells that will bring fluid to surface, and then we'll have 2 injection wells that will send the brine back down into the formation. And those injection wells are situated, they can be about a kilometer and a half away from where the production wells are situated.
Okay, and I'm really curious because it was with this system. Does the what you get out of it diminish over time, or is that fully sustainable? Will keep basically the same flow and heat going?
So that's why we re-inject such a far distance away, so then it can regenerate as it cascades across the formation back to where we produce to surface. So it is fully renewable from that standpoint. Then, yeah.
Okay, and what's the expected lifespan of a well like that? So once you put that in, how long can it generate power for?
So I mean, there's been geothermal facilities generating power, since the 1940s. So I mean, we typically model these to be 40 to 60-year lifespan projects. You do need to go and drill new makeup wells every once in a while. Usually every 10 years or so, you might need to go and drill a new production well. But for the most part, the Earth has been consistently producing heat for millions of years, and so as long as that heat is still down in the formation, we're able to harness it and produce power and direct heat from it.
Okay, and just curious to see how does that compare to like a conventional fossil plant of the economics of it, for example, a coal plant or natural gas plant of your life cycle costs.
Yeah, well, because there's a finite amount of gas under the ground, and so once you drill that well and you exhaust that resource, you're basically done with that well. But we kind of joke a little bit that a lot of oil and gas is actually water production that produces a bit of oil, because a lot of the oil production that you have actually has a large cut of water within it, and quite honestly, if there's too much water in it, it kills the economics for oil and gas
Mm.
operators. And so, because geothermal, the feedstock is essentially free to us, because once the cost is to drill that well, and the production and the injection wells. But once those are in place, that geothermal resource is free to us, and so our feedstock is again regenerating itself and renewable. And so it's a little bit different than where you're pulling that oil out of the ground. Eventually, you're going to exhaust the amount of oil and gas in that formation, and then you have to move to a new location. And because we're also none of the brine that we produce to surface is ever exposed. We don't ever, you don't evaporate any of it off, because there's also lots of dissolved solids and some sour gas in the geothermal brines. It's one of the other reasons that it doesn't ever get exposed to atmosphere. But you don't ever deplete that geothermal brine because it doesn't ever get exposed.
Yeah, so it's total passive tap. You're just kind of cycling around, and I hear you got a steam generator making you electricity, and then you've got this heat. Then you can use in district heating, or like I read on your website, even like heat up a greenhouse or whatever needs heat. Drying the lumber. So it's really interesting what you can co-locate with one of those facilities.
Yeah, and that's kind of why we've picked the location we picked for our geothermal project, is because there's an industrial park being proposed within the allowable distance for us to be able to provide that baseload heat to it. So then we can try to attract co-location opportunities for greenhouses, any major industrial processes. So it's not only are we bringing emission-free heat and power, but it's also a bit of an economic play for those local municipalities that want to get a bit more of a tax base within their own backyard. And so we kind of see it as we're cleaning up the emissions, but we're also trying to bring a little bit more prosperity to these regions that have been hit pretty hard with the downturn of oil and gas as well.
Yeah, and imagine it's a cost competitive energy and heat as well. You're able to compete quite well compared to the alternative, I would imagine.
Yeah, I mean, we model against natural gas. The advantages for us, obviously, is when you combust a gigajoule of natural gas, you have to pay an associated carbon tax with that. And so when if we were just comparing geothermal heat to natural gas, it's very cheap to produce natural gas in Alberta right now. But when you associate that carbon tax with it, that really brings us to par, and typically gives geothermal a pretty good leg up on the traditional means of firing gas for your heating needs.
Great. And I'm curious, what's the potential of this style of conventional, these deep well geothermal? Like how much capacity is there in a place like Alberta or the rest of Canada?
Yeah, Alberta's an interesting place. You can't find conventional geothermal everywhere. We kind of call the renewables of the north is for geothermal. So our project's situated up near Grand Prairie. And so kind of that Grand Prairie area, even getting down to Swan Hills and going north all the way up to, Rainbow Lake, that's where you start to see a lot of the better potential for conventional geothermal. You go to southern Alberta, central Alberta, we've looked at some project opportunities in and around Edmonton, Calgary. It's the geothermal resource just isn't there. You can find specific pockets sometimes, but it's very, very locationally dependent. Unlike a place like, the Caribbean or Iceland, where, they're built off volcanic formations where, you go punch a hole almost anywhere and you're going to find yourself more than enough heat to generate power. But I will say, if we're talking direct heat use, there is absolutely a lot of opportunity around Alberta to be able to harness the Earth's heat for direct heating, for sure.
Okay. Well, great. Thank you for doing that rundown. It's such a great to see. And I love how you said it. It really is baseline. You can turn it on and off at will, and it really can replace the function of natural gas and coal have been doing, where you've got this power you can depend on. So it's really definitely an interesting project. And this one that you call the Alberta #1, and we're in Grand Prairie, I believe you said.
Yeah, just south of the Wapiti River, in near Grand Prairie. Correct. Yeah, and Alberta #1.
Okay. And then how long, and which phase are you in? Has it been total operation, or is it still growing? What's the status of that project?
Yeah, so we're finishing up the well designs to do our first exploration wells for the project, and we're actually still in a capital raise as well to provide some funding for the project. But once we finish up well design, we'll be mobilizing to site to drill 2 exploration wells. And so the first well will be to confirm that we have the temperature resource, and we'll be able to bring some fluid to surface to be able to test, the sour gas components, the dissolved solid components, just to make sure that the composition is there. We'll also get a lot of information on the porosity and permeability of the formation that we're going to be drilling into. And then after that, we'll drill a second exploration well, right beside it. And that's when we'll start doing flow rate testing. So, the technology that we use to generate power requires temperature, flow rates, and uptime. And so 120 degrees Celsius is in the wheelhouse for power generation. That flow rate, like I said, 300 liters a second is a pretty significant rate. And so we'll be extrapolating the findings from these exploration wells based on the flows that we get just from doing a couple slim hole exploration wells. And then from there, that'll tell us whether we're ready to go and start drilling production wells. That will then give us the chance to put the proper size to the power generation facility as well.
Okay. And then how far off before you see being in full production mode?
We're targeting right now Q1 of 2024 for power generation. It's about a 2-year drilling program to get through getting all the wells drilled. And then once we're able to confirm the size of the power facility, we're about a 12 to 14 month manufacturing timeline. And then we have to obviously come in and install it. So based on that, if we're able to get out and drill these exploration wells kind of August to October in that target, we're shooting for Q1 of 2024.
Perfect. And imagine you're in a great area that has a lot of drilling infrastructure and expertise. So it's almost like a perfect marriage of taking this new technology, but really able to use the industrial infrastructure that's out there.
Yeah, we were able to pick this location based on the historical data that came from the oil and gas industry that gave us the confidence that we were going to be picking the right jurisdiction to be drilling for geothermal heat. And then, we're working with one of the oldest drilling contractors in Canada, and they don't have to reconfigure the rig at all. The difference is that the drill bit's just getting bigger, like I said, from those smaller oil and gas wells to these 13 to 14 inch wells. It's basically just a change in the drill bit at the end of the day.
Yeah, amazing. So that's one side of the technology. So I'd love to hear a little bit more about the other side, where you're not drilling in the earth, but you're basically just kind of bringing these technologies and piping yourselves into all sorts of things. I imagine natural gas generation facilities, cement plants, like whoever's making a lot of heat. And tell us a bit more on how that works.
Yeah, so that vertical for our business was born out of this geothermal side of the business. So when we were exploring what technology we wanted to use to generate power from geothermal brine, we also quickly realized, like I mentioned, that flow rate, temperature, and uptime metrics, that as long as we could meet those specific metrics for the waste heat to power engine, it didn't really matter what the feedstock was that it was getting, because again, it just goes into a heat exchanger and then that exchanges it into our working fluid. And so we quickly realized that there's a lot of waste heat available, not just in Alberta, but around the world. 60% of the energy that we produce is lost as waste heat, which is a staggering amount of energy. And not all of it is able to be captured. Some of it's coming out of the tailpipe of your car or your truck that you're just never going to be able to capture. But, at natural gas turbines that are operating like on pipelines at compressor stations, or turbines within oil and gas refineries. There's a lot of high pressure steam within pulp and paper facilities. The cement manufacturing industry has a lot of heating within it. And so there's a lot of opportunities for waste heat recovery. And so Terrapin can bring that same technology, but we also kind of innovated the business model on that side. And what we do is instead of approaching a client and saying, okay, here's the amount of waste heat that we can capture, and this is the amount of power that can be generated, and here's the CapEx for the project, we actually offer to bring that capital to the table and pay for the project and own and operate it ourselves. And then what we do is we offer a gross revenue royalty payment back to that client for access to that waste heat as our feedstock. And so instead of the traditional means of saying, oh, here's an awesome project, you got to pay for it, a lot of these companies that have fallen on hard times and they don't have the capital to be able to deploy for these projects, we can come in and say, we want to not only eliminate your grid draw, which is then going to eliminate some of your carbon footprint, but you don't have to spend a single dollar to reap the benefit. And actually, we can create a profit line item on your balance sheet by offering you a royalty payment for access to your waste heat. And so we've really gotten a lot of good interest on that side, and it seems to be well accepted from the operator side so far.
So basically, you come to them and says, you don't need to spend a dime. Bring this in, and then we'll give you some money every month for what we're able to make off your waste heat.
Exactly. Yeah. So we ball together. If it's in Canada, obviously there's carbon tax that we can make revenue off of, as well as the power sales. And so we offer them a gross revenue royalty payment for that. And obviously, if they said, oh no, we do have the CapEx and we would like to pay for this project and build it, we can sell them the technology and help them get it constructed and implemented as well. We're quite flexible with how we work with our clients.
Okay, so in that way, they pay for the project and they keep the revenue from the sale of the heat. So it's either one or two models.
Exactly.
Wow, so it's really hard for someone to say no in that case.
That's the hope.
And then how quickly has that side of the business been growing?
So we've only been a couple years down that road. So, we're working through due diligence with a couple clients to get our first deployments. So so I will say Terrapin doesn't own the technology. We don't have the IP for the technology that we use to convert the geothermal or the waste heat to power. We work with a technology partner based in Italy. And so we represent them in Western Canada to distribute their technology, and then, in North America as well. And so we're working right now to get their first. They've been deployed all over the world. They've got about 54 operating facilities all over the globe, but they don't have any in North America. And so we're going through some final due diligence activities with a couple of operators to get this technology deployed on the waste heat to power side. Hopefully within the next couple months, we'll have some announceables.
Okay, and then how do you see this waste heat or like deep geothermal market growing in the next decade?
Like I mentioned, when you hear the metric that 60% of the energy that we produce is lost as waste heat, it's everywhere. We've been connecting with groups, in the US, in Latin America, South America, Australia, New Zealand, Indonesia, or Europe. The opportunity is too big for any one company to be able to capture. I would say I would love to capture it all, but it's just too large for us. So, we've really focused on the oil and gas companies because of the replicable opportunities. You can go to the same oil and gas company and they typically have a lot of the same infrastructure. Whereas, on the cement side, you could look at 3 different cement facilities and look at 3 different types of configurations. And so we focused a lot on oil and gas, but there's an opportunity. Data centers are producing waste heat. Heavy manufacturing, it's everywhere. And so we've definitely seen a lot more players pop up in the space over the last couple of years. But competition is good. It means you're doing something right, and you're in the right industry. And so, there's a ton of opportunity, I would say, for waste heat recovery. And I think a lot of the owners are starting to realize this as well, that there is opportunity to be able to solve. It's that circular economy play. They can solve some of their own problems within their own backyard. And so it kind of speaks again to those ESG mandates, environmental social governance mandates, from the board level to start cleaning yourself up. Executive compensations are starting to be tied to how you reduce your emissions, and so their hands are being forced to act. And so it's good. We love seeing it.
Yeah, I love that idea of having the compensation tied to those kind of goals. That makes a lot of sense, right? Because it works well. If you tie it to money, so you're going to see action and results.
Absolutely, yeah. Hit them in the pocketbook, and you definitely will.
Perfect. Yeah, and I love how it's cooling as a problem, all of a sudden it gets kind of turned into as an opportunity of, let's take this this heat we don't want and find a way to reuse it and lower our bills. So it's kind of a beautiful answer to our problem.
Yeah, and some of the sophisticated clients, a lot of them have been using waste heat already within their processes. Generally, not producing. You see steam generation. Cogen. You know about cogeneration, and steam projects are pretty typical. But that lower grade waste heat, kind of below 500 degrees Celsius, there wasn't a lot of focus put on that. It was mostly focused on that heat that they can use for steam power generation. And so I think that's where the shift in this energy transition in this waste heat recovery space has seen a lot of traction, is in that we call it low grade waste heat, but by no means is it low grade. There's still a lot of value in that waste heat.
That's beautiful. Now, what's Terrapin up to next? So what's your next step, or what are you guys looking for? What's the future looking for your company?
Yeah, we're obviously excited to keep advancing the geothermal project here in the province. It would be the first conventional geothermal power project. There's other geothermal projects happening in the province, so we're excited to see some of the regulations in the province kind of get sorted out. There's been some traction with the government on the regulatory side, because there was no geothermal industry before, and so you kind of gotta create the regulations for the companies that want to play in this space. And so we're excited to see some of that getting sorted out. We once we get our first project going, we've got a couple other locations not far from where the Alberta No. 1 project is that we hope to be projects 2 and 3 for us here in Alberta. But we're also excited to kind of take this waste heat business model international as well, and start to solving the problems in some of the larger emitting countries, the US, India, China. We'd love to see some of our projects make their way into those countries and start really knocking off a lot of their carbon footprint, I would say.
So I hear lots of potential.
Lots of potential. Yeah, like I said, it's almost overwhelming, but we're a scrappy group and we're excited to go and try and tackle it.
I love it. And let's say for people listening, what are the opportunities that people can connect with? Because I hear there's some investment opportunities. I don't know if you're looking for people to come and work, or certain specialties, or just people looking to bring some project ideas. So what is it you guys are looking for?
Yeah, because Terrapin works with third-party financing funds a lot of times. So if anybody's interested in investing into, clean emission-free clean energy projects, there is investment opportunities currently available into the Alberta No. 1 geothermal project. We always look to partner with any finance partners on the waste heat to power side as well. To date, we've tried to stay as a small team, just to, keep our burn costs as low as possible. But as we grow, we're going to need more process engineers. On the geothermal side, we're always interested in engaging with other geologists and subsurface folks. Anybody that's kind of plugged into the regulatory space. You can't go about this alone, and we definitely don't want to go about it alone. And so we're always interested in collaborating with other developers as well to explore project opportunities. We're an open book. We're developers at heart, and we love partnerships, and we love working with our friends. And so I can't say that there's any specific one need immediately today, but as this industry grows, it's going to need smart, scrappy people to get involved and help solve a lot of these problems that we're seeing.
Well, thank you for your time and introducing us to the world you're working in, and being such a pioneer in bringing this new technology. So I really hope that you have a chance to really grow this and make a big impact into the issues we're dealing with.
No, and thank you so much for reaching out. I mean, groups like us need people like you to also help us spread the word. Again, we can't do it all by ourselves. We have a marketing team, but to be able to get the reach through a group like yourself, means a lot to companies like us. And so I think I'm even more appreciative of the opportunity to that you gave me. I would think so. Thank you so much.
Well, thank you. enjoy the rest of your beautiful weekend.
Yeah, you as well.